In this video, we're going to talk about exponential functions. Well, let's take a look at an exponential. So we know 2 to the first is equal to 2, and 2 squared is equal to 4, and 2 cubed is equal to 8. All of these are examples of exponents. So I can rewrite as 2 to the x equal to y. X would be the domain of the exponential value, and y is the range there. So 2 to the x equal to f of x is an example of an exponential function. Notice where the variable is. The variable is in the exponential power instead of the base. So an exponential function with base a is a function of the form f of x equal to a to the x, where a and x are real numbers such that a is greater than 0 and a cannot equal 1. Well, why is a greater than 0? Well, let a equal -2 and x equal to 1/2. If I plug that in to the form above, that's -2 to the 1/2. Well, I can rewrite that as square root of -2. This is not a real number, right? Which is why we would always like to have a be greater than 0. Now, the other question we need to ask is, well, what happens if a is equal to 1? Plug it above, that's 1 to the x. Well, 1 to any particular power is 1. That is a constant function, and we do not want that here either. Okay, so that is why we have the restrictions the way we do. Okay, so now what I want to be able to do is to graph exponential functions. So let's graph a real basic one. Let's graph f of x is equal to 2 to the x by plotting points. Now, what I would like to do is I'd like to do 5 points. Okay, so I'm going to create a table of values because anytime I don't know what a graph looks like, a table of values is a good place to start. So I'm going to pick values that are both positive and negative. So in this case, I'll pick from -2 to 2. Okay, so plug in. It's 2 to the -2nd. That's the same thing as 1 divided by 2 squared, which is 1/4. Okay. Similar argument for -1. We know 2 to the 0 is 1, 2 to the first is 2, and 2 squared is 4. Okay. So what am I going to do? I'm going to cross this off and make this f of x because it is functions. I will rewrite that and that, and I'm going to plot points. Okay. So we know that -2 and 1/4, that's going to be about here. We got -1.5, that's about here. 0, 1, 1, 2, and then 2, 4. Okay, so connect. Okay. Now, let's talk about some of the characteristics for this. Okay? And I'll write this below, maybe in a different color. Okay? So the domain. Well, the domain is all real numbers. There's no restrictions on what values I can plug into this function. Now, the range, on the other hand, okay, that is never going to be 0, and it's not going to be negative. Okay? As x is getting smaller, I am approaching 0. Okay? But I'm never going to be 0. Okay? So 0 is not included, but it goes to positive infinity. Okay? Now, x-intercept, well, that's where it crosses the x-axis, and that is going to not exist. Okay? It does not touch the x-axis. The y-intercept is 1. So I know that ordered pair is 0, 1. Okay. Notice, this is always increasing. Okay. So it's increasing from negative infinity to positive infinity. Okay. Now, notice, because it's never going to be 0, we have a horizontal asymptote at y equal to 0. Notice the horizontal line that I'm trying to draw here. Okay? And it is a one-to-one function. Now, what is the significance for that? Because this is a one-to-one function, that means this function has an inverse. We'll talk about what that inverse looks like later on. Okay, so the other one I want to graph right now is g of x is equal to 1/2 to the x power. Now again, before I do anything else, I'm going to create a table of values for this to see what this looks like and how this is going to be different from the problem that we just finished doing. So I'm going to pick the same domain values from -2 to 2. And again, when I plug this in, we know that's the same thing as 2 to the first squared, which is 4. Okay. Similar argument for the 1/2. That's the same thing as 2 to the first, which is 2. Plugging in 0, that's still 1. And we have 1/2. And 1/2 squared is 1/4. 1/2 times 1/2. Okay. Okay, so similarly to what I did above here, I'm going to change the y to g of x. Okay, and I'll label these as such. Okay. Okay, so now I want to plot -2 and 4, and -1, 2, and 0, 1, and 1 and 1/2, and then 2 and 1/4. Okay. So again, a lot of the same characteristics. So again, we can go through this now. Again, I'll do this in a different color. But the domain is still -infinity to infinity. The range is still 0 to infinity. Again, not including 0. Okay. There is no x-intercept. The y-intercept is 1, meaning I can write that as the word pair 0, 1. Okay. Now, you still have a horizontal asymptote at y equal to 0. Again, notice going horizontally across as I've just drawn there. But what makes this different? It is decreasing all the time instead of increasing on the previous problem. Okay? This function is never increasing, and it is never constant. Okay? So the other nice part is this is still a one-to-one function, meaning that this function, like the previous one, does have an inverse.